Bismillahirrahmanirrahim. Assalamu alaikum students. So class 8, today we are going to continue our 8th unit and do a second part of it that includes visualization of a chemical reaction. We are going through a chemical change, how can we balance a chemical equation, and what are the indicators of a chemical reaction. So now we are going to visualize a chemical reaction. Visualize, we're going to see a chemical reaction. For an example, in an equation of sodium, that is Na, and chloride, that is Cl2, chlorine gas, when we combine two elements, these are our reactants, sodium and chlorine. The chemical formula by this combination reaction is NaCl. The product NaCl is formed. NaCl's common name is table salt. The salt which we eat in our food is basically a form of NaCl crystals. After adding these two elements and writing the correct formula, we are going to balance it. Chlorine 2 atoms, chlorine gas, then we will add 2 here to make this chlorine 2 and sodium 2. We added 2 on both sides. Now we can say that in this sodium, 10 moles of sodium, for an example, added to 5 moles of chlorine gas. Chlorine gas means that 5 into 2, that is 10. So basically there are 10 atoms of chlorine result into the 10 mole of sodium chloride. So 1 mole is equal to 1 gram of that substance or that element. 1 gram of sodium, 1 mole of sodium is one and the same thing. So if it is 10 moles of sodium, then here it is also 10 moles of chlorine. Why 5 here and 5 into 2? Because there are 2 atoms of chlorine together. So both are 10 here and 10 here. Here they are independent 10 moles, whereas here it is in the form of chlorine gas. So every chlorine atom is in its molecular form, that is Cl2. When these two react, a product is formed, that is sodium chloride having 10 moles. It means 10 grams of sodium chloride. I hope you understood this chemical equation visually, that what was happening inside when sodium was combined with chlorine. When any reaction takes place, it involves the use of heat or energy. In some reactions, energy is conserved, and you know that energy can neither be created nor destroyed, but it transforms from one position to another position. It may be released, it may be conserved. So before a reaction and after a reaction, one of this activity will take place, whether the energy is released and cooling effect takes place, whether the energy is conserved and heating effect takes place. So in any chemical equation, whether cooling takes place or heating takes place, so when the heat is involved and a reaction takes place and heating effect is there, it means it is an endothermic reaction. And when the heat is released, then it means that an exothermic reaction has taken place and the heat is being released. So there are two kinds of reactions, endothermic reaction and exothermic reaction. Here you can see in endothermic reaction, it is a reaction in which is cooler than the surroundings. The reaction inside is cooler than the surroundings. It means it is an endothermic reaction. Whereas if the surrounding is hotter, then it is an exothermic reaction. So the definitions of both reactions are: a reaction in which heat is given out is an exothermic reaction, a reaction in which heat is taken in is an endothermic reaction. These are the definitions of both the reaction. Any reaction can either be endothermic or could be exothermic. And repeating it again, a reaction in which heat is given out is an exothermic reaction, and a reaction in which heat is taken in is an endothermic reaction. So heat reaction. Basically, exo and endothermic reactions are on the basis of heat. So these are called heat reactions. And you can see this triangle here. It means enthalpy. It is known as enthalpy, and this triangle represents change, enthalpy change in heat. Triangle of H means change in heat. So the heat reaction of a chemical reaction is in the heat is released in the units of kilojoules. Heat is released in the form of kilojoules, and when some number of moles of a substance in the reactant site and number of moles of substance on the product sides must be balanced completely. For any exothermic reaction, the enthalpy of heat is negative, and for any endothermic reaction, the enthalpy of heat is positive. That means that in exothermic reactions, the enthalpy change is mentioned to be negative, and in endothermic reaction, the enthalpy of heat or change is said to be positive. Here you can see exothermic reaction, heat is given out, combustion means burning takes place, and this is a warmer condition, getting warmed and energy is released. Whereas in this case it is an endothermic reaction, heat is given in and the ice melts, so it is a thermal reaction in which cooling effects takes place. So if we compare these two reactions, what is the difference between both the reaction? In exothermic reaction, heat is given out to the surroundings. That means in this case, when I will hold a bottle, I will feel the heatening effect on my fingertips. If I hold a bottle in which exothermic reaction has taken place, that bottle will be hotter because energy is getting released and the enthalpy change H is negative. In exothermic reaction it will be negative. Whereas in endothermic reaction, when I will hold a bottle having an endothermic reaction, the energy is taken in, and when I will hold a bottle in endothermic reaction, I will feel the sensation of coldness or coolness. That is an endothermic reaction in which the change in heat is positive, enthalpy change is positive. So in endothermic reaction, the reactants have more heat, uh, the reactants have less heat than the products, because it is having a in which the reactants release energy, whereas in endothermic reaction the products have more energy than the reactants. If you could understand it better, that the products which we use here had less energy, whereas the reactants had more. In this case, the products have more energy and the reactants had less. So the activation energy, every reaction has an activation energy limit in which the proper heat effect on which any reaction starts working. For an example, in this graph you can see a reaction is taking place, that is an exothermic reaction in which reactants and products are in line. And what happens is that in this case what happens is a midpoint arises, and in that midpoint the level of heat is up to that extent that activation energies term is satisfied, the point at which the activation of that chemical reaction takes place, the optimum energy limit from where a chemical equation starts working or acting. So the activation energy in an endothermic reaction takes place when the amount of activated energy and the energy released is up to the same level. Here you are viewing, whereas in endothermic reaction activation energy takes place when in the middle part, when the amount of heat in the reactant side is maximum. This is the point where the activation energy is up to that limit that starts off or kicks off a chemical reaction in endothermic reactions. And here these are just comparisons to get a better picture of both the endothermic and exothermic reactions, nothing more, just different way of explaining the same reactions again and again. So I hope you understood it. Thank you, class.